So today I want to try to fix a bug that we found in the Zig compiler last stream. The bug is if we have a library that we are compiling and expecting to runtime load with like DL open. As an example, maybe we have a VLC plugin that we're trying to load, right? We want to write the plugin in Zig. This result, the standard library will use thread local variables to like cache stuff. For example, the current thread ID. And accessing those thread local variables goes through this function call in libc when libc is linked, not when libc is not linked, but when libc is linked, it goes through this this function. Let's see if we can find it. Maybe if we do an obj dump here, obj dump -d zig out lib this guy. Can we look for thread local storage getter? This guy. So we go through this function, thread local storage get adder. And this function is like a C ABI function. And usually, if you like link a library normally, this goes through like some fast cache path. It doesn't fuck up any of like the registers that we were expecting to see. But if you're in a shared, if you're like a runtime loaded shared object, it ends up in this like slow path, which does a bunch of stuff. And by doing a bunch of stuff, he might zero out some of the registers that like are expected to be scratch registers according to the x86 system v calling convention, right? So it's kind of like expected that if I am calling a C function, I need to back up registers that I care about as the caller. And the bug is that Zig does not do this. It does correctly handle this for external C functions, right? So if we were to actually call a function, how do I say this? If we were to actually call a function that was properly imported from Zig as like a C calling convention function, he correctly backs up all the stuff we care about. But in this case, he does not. And so that results in when we return an error, he will go try to access the thing that he previously held in a register, and he will go boom, boom, segfault. And so I think I would like to try to fix that bug. I think it's possible. I think we can do it. But I think I am pretty fucking lost in the Zig codebase, and so it'll be like a little bit of work, and we're going to make a lot of statements that are probably untrue, and we're going to get lost a lot, and it's going to be fun. I did start looking at this yesterday because I didn't think I was going to stream it. I thought like maybe I'll just make a quick fix off stream, but it's not a quick fix because I'm stupid. But my current understanding of Zig's pipeline, which I think we'll look at the code as I'm saying this because I'm not 100% sure about this. But it's like something like this. So, obviously there's going to be some part of Zig's codebase that takes in the source code and turns it into an AST, right? Like an abstract syntax tree. Everyone fucking does this, and then they're going to like analyze this thing and turn it into, I think it turns into Zig intermediate representation, I think it's called. Right? Zig intermediate representation. So ASTgen converts AST nodes into some untyped IR instructions. Next, Sema processes these into AIR. So does AIR, Zig tells what that is. Analyzed intermediate representation. This data is produced by Sema and consumed by CodeGen. Unlike ZIR, where there's one instance for an entire source file, each function gets its own AIR instance. So I guess, my guess here would be that ZIR is like pretty like stupid, maybe like almost like one-to-one mapping, maybe, I don't really know. And then Sema, I feel like I see a lot of stuff in Sema, and I feel like I see them doing like, this would be kind of like machine agnostic, backend agnostic, like how are we going to process stuff? I think that a lot of the work is in here. This is a 37,000 line file. What do we have in ASTgen? This is 14,000. So I haven't really looked at ASTgen at all. I've like never opened this file before. But that's okay. So we go AST to ZIR, to AIR. So this is, maybe we write here, okay, if we do this, we can kind of specifically write ASTgen here. We can write SEMA here. And then CodeGen, I think, is actually not a output. I think CodeGen is here, I think. And then I don't know what comes next. So at some point, somebody, somewhere, is going to... that's what they said, right? They said in the AIR, they said consumed by CodeGen. And if you look at like CodeGen, there's a lot of these different implementations, right? So there's like the x86-64 CodeGen. So I guess maybe what might be interesting is trying to figure out who calls this. I don't really know how this pieces together yet. Or maybe we go to the next stage. Okay. So the thing that we're trying to figure out, we're looking for two things. One is we are looking for how Zig's compiler normally backs up our error trace register, right? We know that happens if we do a proper C function call. So that's one thing we're looking for. The other thing we're looking for is how does Zig's end up calling this thread local storage get address function, right? And we found this last stream. If you just search for like TLS get adder or something, this is in a level that we haven't found yet. CodeGen x86-64 emit. And it looks like this is in some sort of like big loop where he's taking some sort of something and emit machine instruction, right? So this is like, I don't know if this means that he's making mir. So this is probably part of CodeGen, right? Right, like if we look for, who would call this? Here it looks like we have, okay, this is in RISC-V, which is not helpful. But this is in a function emit. Is there like an x86 version of this thing? CodeGen x86 mir emit. And this is calling emit mir. So it's probably here somewhere. So who calls this? I don't have a language server set up that can handle Zig 16 yet. So we'll get there. Okay, so who calls, like, how do we make this thing? Does somebody like, is there like an init function on this or what? Scrolling up, scrolling. Okay, I guess, can we look for calls to emit maybe? This is like a generic source CodeGen. Nice. Okay, so here in CodeGen, they have like a generic CodeGen, not platform specific. They have emit function in here. So like, if I am making an elf file, I might, as I'm walking through functions that I'm trying to make, probably coming from, not sure yet. But at somewhere they go, I want to emit a function. So what are they emitting? Where is the function? Source lock? Func owner nav. So func is func info, func index. Got it. So they're looping over all functions. And they are saying, hey, from this Zig compilation unit, which is coming from some per thread data, I guess. I guess maybe the Zig compiler is maybe running in parallel, and so like each thread is responsible for some compilation units or something, and so this is probably like the current compilation unit that he's working on or something. And so in here he's like, yo, I'm going to generate some code for this function in this compilation unit, and in there I'm going to emit function, which is going to eventually get into mir emit, which is where we found in here that like thread local storage get adder, right? So this is kind of at like the very, very end of the stage. This stage, I guess, is it like the very, very end of this? I think. Because like in this mer emit, I believe if I understood what I was looking at earlier correctly, we already have a bunch of machine instruction, like MIR instructions at this point, right? So I think in like code gen, in here, we might have, I saw something called like gen call at some point. So in here, we might have something who's like, I believe, like, just let's look at like any function in here, right? So let's look for like where he's actually doing some function calling. So let's say he's doing like an indirect jump, right? He's like calling self gen set reg. And in here, he might call self gen set reg again. Oh, it's the same fucking function. We define a different one. ASM register immediate. And in here, he's saying like self add instruction, right? And this is doing what? He's appending into mer instructions somewhere, right? So this guy, code gen, is generating these instructions. We probably have this list of mer instructions by the time we're emitting it, I would assume, but I don't actually know that. So maybe we can double check this. So who calls update func? Well, okay, let's go into code gen here and just try to find like anything that ties this back to something external, like how this like ties into the entire Zig compilation pipeline, I guess. Okay, so this is like a mega function that I think must be looping over like AIR output, I guess. For body is a list of analyzed instructions. Yeah, so gen body is coming from gen body block or something. Gen body block is coming from lower switch AIR loop switch. Oops, we've kind of cycled. We've cycled. Gen body. Gen main body, maybe? Function gen, we're getting closer. Function gen here on pub function generate. Nice. Who calls this? Probably in like common code gen, right? Yeah, here we go. Okay, so we have generate function here, which we found before. And then we're looking for like generate function here. Per thread generate function, run code gen inner, run code gen in per thread. Okay. So this is kind of like towards the top level of this like compilation thing, right? Looks like it. Someone's like pushing code gen func jobs somewhere. Who's pushing these? Who is pushing these? This guy. Per thread, analyze function body, which is happening on... Oh yeah, we kind of saw this. So this is on the Z compilation function info, and this is coming from what? Like, is this ZIR? Is this ZIR? I don't know at this point. I'm lost. Analyze function body, ensure func body up to date. Ensure func body up to date comes from Sema, which is in charge of doing ZIR to AIR, according to the thing on the right that we made up, kind of. Okay, cool. Okay, so what did we learn there? It's that we figured out that the part that is generating MIR instructions is called from... How did we get here? Code gen. So code gen, Sema's outputting AIR and then queuing up code gen jobs that will generate MIR on emit function. Yes. I see. And then as we emit MIR, no, wait, hold on. Generate MIR somewhere. When do we emit it? I feel like we haven't tied that back yet. So there's like generate emit in X cogen. And I'm not really sure what where those guys kind of end up. So we have generate, which we know is called from like sema stuff. When is emit called? Oh, in generate. Wait, it is in generate. Oh, so maybe it's just back to back. Oh, it's back to back. It's a back to back. So we have in generate, this guy does a bunch of code generation stuff like here, and then we should see an emit at the end. Oh, here he just returns it. And then maybe from there he emits it? Oh yeah, because this source code gen. Okay, so this guy returns an anymer. This guy returns an anymer, which makes it all the way up here somewhere. And if he gets a mer, this guy has an output value here. What is out here? Link.zip. Wow. Shared mer. Oh, I see. So this goes into like this guy somewhere, and then where does emit happen? I guess maybe that happens in the linking stage or something, somehow. We saw emission come from like elf, maybe? I feel like we saw that in the code path somewhere, which would kind of make sense. Right, we saw this guy emit mer. I actually don't know. We have saw there's emit lazy here, but I don't think emit lazy is the same. Emit here. I'm lost again. Mer emit on emit function, which is in elf. Yeah. So by default, I love you read and skipped a comment that it wasn't emitted. Look, we're very skimmy around here. So okay, I guess that means that like it's kind of at some point during linking, it's like up to someone to determine if we actually have to emit this stuff. Right, which is probably I bet you this is related to why you have like the check step that can make things way faster, right? In that like a lot of this code isn't actually run unless you're writing the binary right now type shit. Okay. So we know, does it have to get even smaller? Related, like, fuck, there's too much text on the screen. Okay. Okay, so we know that, hold on, can we, how do I remove this bar line again? I can't remember a set. Oh, fuck. Neovim, remove, status bar. Last status, maybe? Yeah, there we go. Okay, so it's like, TLS get adder is injected in emit stage. Emit is only called via elf writing. Code gen is done earlier, which has, fine, I'll spell role-playing right. Thank you. Code gen is done earlier, which has more context. I believe our fix goes here. Or like, I believe, I guess I should say, C call conv stuff, like register backup, lives here. I believe this because of some stuff that we haven't seen yet on the stream, because I was doing some digging yesterday, but this is what my understanding. So I was looking at the, okay, so where is the seg fault? We haven't really covered that yet, but it is in the standard library in built-in.zig. There is this return error function. And what this return error function does is like the compiler injects this when you return an error. And he will look at this error return trace built in, and he will just set something in this trace to this address, right? So this is so when you look at an error, you can like get the nice backtrace, right? If I like go into a Zig executable and I go like something.zig, and I do like pub function main void try do something here, and I have like a function do something which can also return an error. This guy is like right? When I run what is it? Something.zig. Right, this backtrace here, this is kind of done by every time we return, that built-in return error function like injects the next return address into that stack trace. And that stack trace is like passed into every function as like a hidden parameter that you don't really see. And so that's kind of what we're seeing here, is the compiler will do that but through this function. And so this is kind of where we're seg faulting. In my current understanding of the problem is that we are trying to access this error return trace variable that isn't set up properly. So I started looking for I started grepping for like error return trace. And then you can see like, okay, somebody's mapping this guy to this guy, right? So this is it. Then you can kind of start looking for error return trace, which we see a lot of in Sema, right? And we start seeing people talk about like return trace index in here, and somewhere I think I found that this will often turn into, or maybe I started looking for error return trace index like this. Did I find this in Sema maybe, or like in per thread stuff? Yeah, so I saw that like when they do function body analysis, they kind of like preset some sort of like error return trace thing in here. And so then I started looking for error return trace index. And then probably in here I found something. At some point it like maps to a shorter version of the word that has like instead of error. Where did I find that? Where did I find that? Not in here. Maybe here, old. Error return trace index. Maybe I saw this, and I maybe followed this somewhere. Maybe I followed this somewhere. I'm not sure. I'm not sure how I got through this. Maybe I started like just looking in CodeGen for like error. Yeah, I saw this somewhere. Error return trace index. Error return trace in here. Yeah. I found this guy, which was not very helpful, actually. This is not how I ended up where I wanted to go. I think actually where I ended up was I started looking for like function call type shit. I ended up at gen call in here somehow. I don't know how I ended up here when I was searching through this, but I was probably searching for this error return trace reg, which I don't know how I ran into this guy. I don't know how. Oh, maybe I was searching for this like index variable and I ended up here. Anyways, I was searching through the code for stuff that looked error return trace related. And then I ended up in this gen call thing somewhere. Gen call. And in here I started seeing things that say like spill caller preserved registers. And I'm like, oh, this looks promising. I haven't really confirmed that this is what I think it is, but this feels a lot like the correct code for when we're calling like a C ABI function, where we see things like, hey, if we have an error return trace register, can we like maybe set that register? You know, maybe sometimes because like maybe we might clobber it, something like that. I don't really know. So I think what the next step I wanted to take was trying to like fuck up the output, like fuck it up for normal, for like the case that currently works. And then once we understand that, we can kind of like figure out how to like fix that in the other case. You know what I mean? It also feels to me like the correct place to handle this, if I understand this correctly, is in like the generate step of machine instructions, where like the thread local storage thing is injected at the emit stage, which is kind of fucking weird. So we might have to do something like check if we're going to emit a function call when we're doing thread local access and then inject something. I don't know yet. I don't know. Are there GUI libs for Zig? I wrote one. It's pretty shit. It doesn't really work, but that's my fix to this problem. I didn't really look. I think other people have a better answer for if there's like actual libraries people use. But my solution to this problem was just write my own, because that's more fun. Okay, so I suspect if we see stuff like this, so then like somewhere in this function, I feel like there's something we can comment out to fuck up register restoration. And so I think what I want to do is I want to create a little test case that does the right thing. Hold on. Zig, where is our Zig build? And then we have stage 3 Zig. Yeah, okay. Oh, gross. Are we in the wrong environment? Maybe we are. Do you have a stage 3 for the current master? Yeah. Excuse me, why is this file 180,000 lines long? I wasn't asking questions. I think it's because they kind of want all of the like x86 code gen in one spot. I think a lot of it is like there's mega big switches, and it's just like what you're gonna do, you know? Like I think that I think that there are cases where they're just like insanely large switches, and then instead of splitting out like what those things do into separate files, they just kind of like roll with it. But I don't know. Why the fuck doesn't this work? That's not good. Hold on. This is some like oh, maybe it's an install. Maybe that's where it is. It's supposed to be in stage 3 or build in. Hold on. Also, I think I'm in the wrong environment in this shell. Hold on. We gotta get everyone in the right spot. Fucking Nix shit, dude. Auto format on save would never. Yeah. Okay, what am I doing? I'm trying to see if this built Zig will fucking work. So I'm looking at build install this. Yeah, and he's like, I can't find these shared libraries. So probably I need to do some like LD library path shenanigans. God, that's annoying. Env grep. Maybe it's like LVM config. How do I like find my libraries? Which LLVM config maybe? This lives over here, so it's probably my lib standard C++ is probably over here somewhere. No? Oh fuck. Env grep LLVM. Maybe here? Lib std. Nope, that's not where it lives. Maybe it's part of Clang. Maybe in here. Fuck me, dude. Fuck me. Why? Why? Dude, that's so stupid. Where does he think it is? When he built, he must have found it because he linked against it. Like, what the fuck? Can we, like, touch something and recompile? It is just lib standard C++. Why does he even need that? Because libc is linking to glibc. Maybe this is like some like... Do I need to like specifically add this to my environment? Is it something stupid like that? Nix lib stdc++. Not found. This is so stupid. Lib std cxx clang. Lib. No. Lies. 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 Lies, 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 lies. Fucking Nix, man. Not helpful. Not helpful. Someone just give me the fucking package. This guy. Oh, he tried this. I see. Packages, deadenv, cc lib, Jesus Christ. Alright, fine. Fine. It's like this, I think. Is this how you do this? I don't fucking remember. I don't fucking remember. Let's see. Why isn't your compiler? Yeah, I don't fucking know, man. I think they probably RPath. They probably like patch things in RPath libstd C++ often. I don't fucking know, man. So it looks like that worked. Is lib standard C++ in here? Yes. But I forgot a little lib in here. We won't question it. I love and hate Nix. Glad to see there are other people in the paint. Yeah, I have like a love-hate relationship with it too. There are some things about it that are cool, and some things about it that are fucking annoying, man. LGD builds stage 3 Zig. Please, God. Resolves. Thank God. Okay. So now we should be able to, like, go build our fucking test thing. Zig build stage 3 bin. Zig build. Thank God, dude. Jesus Christ. No add C source file. Interesting. Probably it's changed. Add C source file. Add C source file. Seems like it should exist. Oh, it's only on the root module now. I see. Add C. This is root module now. Okay. And then link libc. I assume that this is also root module now. Link libc doesn't exist anymore anywhere. Git log -p. Link libc. All right. Remove handful of things deprecated during the 015 release cycle. Okay, but like, oh, use compile root module link libc is true. Okay. If you say so. Link library. Is that in the same one? Yeah. Root module. All right. Good. It still breaks. And we have something that builds, and now we can start doing stuff like, let's modify this thing so that instead of doing the broken thing, which is this, can we do like call extern function? We do this instead. And so here we should see him emit some assembly that does something sane. Extern, not call external function. We'll just call it external function, like C provided function maybe. And we'll call this C provided function. Returns 932. All right, and then we should be able to build this. And he's gonna be like, yo, I can't find that function. So we need to then so.c, we're gonna have some sort of like C provided function, takes in void, and he returns an int. Return 4, great. And then in build zig, so.zig, this guy says root module add C source file. Who's got the file is B path, C share as part of the shared object. Oh, so.c, not the other way around. All right, there we go. And so now both of these guys should succeed, I think. So if I run like my dl.exe, he's happy, and we can look at this thing. And we can look for, what is it? It's like C provided. And we should see this. This is the important piece here. Is he, after calling this guy, he restores the stack pointer, or he restores the return trace from the stack because he knows he needs to. Which is the piece that we're missing. So if we can get this guy to disappear, then I think that we'll know we did something correct and that we like understand where that code is emitted. You know what I mean? You know what I mean? So I think this is in x86-64 code gen. And I think this is in gen call. This is my suspicion. I don't know exactly where yet, but I know that, how do I say this? Like, this error return trace register thing sounds, oh, what the fuck? Oh, there we go, I accidentally pasted something. I know that this guy feels relevant, right? So what's happening here? If we have an error return trace, and if this return trace register is not equal to register, then we go into this block. What is reg here? Oh, here, this is this. So if they are if these are not equal in that like the instance tracking pointer does not point to this thing correctly, then he says generate set register, right? So I'm assuming that this is the interesting piece here, right? right? This gen set reg of setting the error return trace register to the correct thing. I'm assuming that this is the line that's relevant. And then I don't know how to. I think there was a special way to build the next version of the SIG compiler. I haven't got there yet. So if we go to the README, they talk about a stage 4 compiler, I think, that we have to build. Contributing, testing. Here we go. Editing source code. Here we go. So here we want to do this. Build with master. Fuck. Maybe, am I supposed to do this in build? Or maybe I'm supposed to do like this. Beautiful. Beautiful. Now we give this guy a second. He said it is expected to take 20 seconds. My phone fell in my pocket again. Every day, baby. So then we should be able to try to use the stage 4 compiler. Which is coming from Zig build stage. Maybe this is, where does this go? Stage 4 bin Zig. Ah, here we go. Dude, why is this taking like a year? What is it doing? Am I in the right folder? Yeah, I am. Build command crash. That's interesting. Okay, can we undo our changes? Does this work if we do this the normal way? Wow, this is going to be... We have to keep in mind that this is fucking painful to test. Yeah, interesting. Interesting. What are the stages in Zig compiler? I think it's like one of them is like you're bootstrapping, so you're going from like a shitty C++ version of Zig to like one that can kind of build Zig with more features. Then you build Zig with more features to get stage 3. So it's like stage... Yeah, I'm not sure. There's like stage 1 and stage 2. I'm not really sure how they'll play. Stage 3 is like a proper Zig compiler, and stage 4 is like my modified one. Okay, so let's make sure that this is like just built in its current state. Oh yeah, that's expected. Okay, so now let's make our little patch build again. And so I guess there's like a good chance that we might have to like clear out the Zig cache or something when we're making changes like this. Something like that. So let's do this and then like this. And we're hoping to see if we understand this correctly, that would cause the restoration of the error trace register to not show up after the call, and then we should segfault in the same way. But it said the build command just crashed. So maybe the patch that we're making is just like really fucking shit up. That's kind of funny. Oh, I guess because this, like, generating the build script also uses this. So we need this to have some sort of like option that triggers it or something. Right? Like, otherwise this will happen. We only want this to happen in our like one spot. Fuck. Yeah, how is there like ways for us to switch on like Zig compiler options? Like, how do I get like -f options in here? You know? Or maybe I can do an env environment variable test. That's probably the way, right? No, because the environment variable will be set for the build script run as well. Maybe we just don't go through zig build. If we do like zig stage 4 bin zig build lib, can we somehow get this to kind of emit the thing and then the build command won't crash? You know what I mean? Okay. How do I make this guy make a dynamic library? -O looks promising. O format. However, that doesn't look like it. I don't see anything about like shared object in here. I guess we can look at what the build.zig does. When we have like dynamic linkage in here. Was this like stood build compile linkage? Maybe does it by output? Can I set the output name? Maybe? Yeah, they kind of have this like outlib file name. Maybe it's something like that. Can I specify my output file name? Is that allowed? Compilation unit name, not a file path. Target output. How do I set like the file name? This is so confusing. Zig build. Let's maybe ask the idiot because I can't find it. How do I make zig build lib emit a shared object? No. Use the build system. No. No. I want build lib to do it. Is that true? He's just a lying piece of shit. Liar. I guess there's like that -O flag. Well, he's probably confused as fuck, to be honest. He looks like he's just fucking throwing like normal he's throwing like GCC arguments at it because he doesn't fucking know. Will this be a YouTube video? Unclear. I'll decide after. Maybe not, but maybe. Yeah, I feel like the answers, like in, like get zig args here. Can we look for like linkage in here? Here, zig args append dash dynamic. Maybe. Let's go, baby. Let's go. Okay. So can we then look at this lib.so and look for do something? And we're hoping to see that after the call to C provided function, we no longer see the restoration of R9, which is indicative that we're doing that we have this correct. So now we should see the same behavior where he segfaults unconditionally now. Yes. And we should see this in the same spot. No GDB, are you kidding me? Are you fucking kidding me right now? Are you freaking kidding me? Unbelievable. So yeah, this is the same fucking error, right? So by removing that one line, we have in fact fixed or like caused the same behavior. Which was in gen call somewhere. So we now have somewhere. Wait, where was it? Where's our commented out line? Oh fuck. Oh fuck. Wait, where'd it go? Error. Where'd it go? What the fuck? Did I remove the change? Is that why? Ah, fuck. Ah, fuck. Gen call. Fuck. Okay, it was in here somewhere. It would have been. It was this one, right? I think it was this one. Okay, wait, hold on. We run through this whole set of experiments again. So we build stage 4. We might be confused. Okay, so we build stage 4 with stage 3. That is the one with our changes. I believe it was line 176257. I can't tell if you're joking or if you're serious, but either way, that's funny. How would you reply if you were called an idiot all the time? So true, so true. Okay, so then we want to do zig build. We want to do this build with stage 3, I think. Right, so I think I want to go like stage 3. I'm not really sure what I want, but we'll figure it out. Oh, fuck. Zig, build, stage 3. Bin zig, build. So this will build everything the normal way, and then we want to use stage 4 to call that build lib thing. Great, and we want to move libso.so to zig out lib. Then we want to run like this. And we're hoping that this doesn't segfault because our change is not in. Perfect. Okay, and then same like this. Okay, right. Now we make our change again, which was this one. Do that whole fucking shebang again, which is annoying. There's too many things to remember. My brain can't keep all of these little commands in my brain at once, but we're getting somewhere. Okay. Build lib with stage 4. We move this guy over there, and now we segfault. Okay, perfect. Perfect. Okay, this is what I expect. This is what I expect. So we have proven that we can fuck up the normal function calls, which is good. Now, the question is how the fuck does this result in that behavior? Right? So like what is this function doing is like the question, right? We can assume generating call. Generating call. I wonder if there's a way to like get this to dump out what he's doing. That would be hype. If we could like just like what is this guy generating? He's generating machine instructions from analyzed instructions, right? So if we could like just turn on some like super logging at this point, that would be kind of cool. I don't know if that's really doable. Okay, I guess we skim. So we have, what is he doing? He is saying, give me the function type. if this is an external function, which in this case it kind of yeah, we're calling an external function. So this is going to be the case that we're in, probably. We have param types, return type, and calling convention here, where this is going to, CC here is going to be the C calling convention. Then we're going to come down here. He's got some stack space that he's dealing with. Oh, interesting. That's cool. They have like a stack allocator. Neat. This is oh, never mind. Maybe this is a local stack. I actually don't know. Interesting. Okay. So then they allocate some space for arguments. Wonderful. They do something about some frame indexes, and then they lock some. They have some stuff about like register locks. I assume that this is like x86 64 register allocation. Like, where do I put each parameter? Probably uses like this is probably to make sure that you don't like try to assign the same variable to two registers. Would be my guess. So then they resolve calling convention values given the function information, where function info is related to the fact that this is like an external function. Where I assume this doesn't actually do anything. I assume that this is kind of more about just like, let me know what's in this thing, not like emit some fucking shit. You know what I mean? Yeah, I don't see any like code generation going on here. I think this is just like a lot of process one type and turn it into another. I think. Is Zig an LVM compiler? So the case that we are falling over in is when we are not compiling with LLVM. So Zig has like two backends. He has like, I will compile with LLVM, and I will compile with like all this code that we wrote ourselves. And I'm assuming that this function I'm in right now is unrelated to the LLVM code path. We should actually check that. I'm not 100% on that, but I do. That's my like the feeling I get. So probably like, I assume that codegen.zig or something. Probably. Yeah, we have LLVM right in here. So how does he determine what platform he is, right? Compiler backend here. Built-in compiler backend. So self-hosted compiler of Zig x86 or using the LVM backend. Okay, cool. Yeah. Makes sense. So this codegen stuff is all specifically this is not using LVM. So basically the goal of this stream is to make it so that returning errors for x86 64 Zig output won't segfault. Yes, in this very specific case where we access a thread local variable and then access the error trace. It's like this like very, very specific case. So here, then this looks a lot like something related to making sure we back up our registers correctly. What does spill mean here? Spill E flags if occupied, spill call or preserve registers, right? So this is interesting. It is also interesting that they're passing in the error trace here, specifically. Ignore register. Okay, but what is like spilling doing? Am I crazy that this doesn't look like it's doing anything? I guess maybe get known reg might do something. Get reg index. It doesn't seem like this is doing any work. Am I high? If for get caller preserve registers, get known reg, which calls get reg index, spills the register if it is currently allocated. Spill instruction. Is this like backing stuff up to the stack, maybe? I don't really know what this is. Self-spilled append in mock. So in like x86, spill. Gen copy. Spill from this to that. Where there's like self short and self long. What is a copy? Ah, I see. So there's these like MC values. MC value in the house. Which maybe is in memory. Yeah, I think I understand. So probably this is finding another place to house things. Right? And he is spilling... allocate or reuse frame index. Yeah. Alloc reg or mem. Yes. Okay, so I'm guessing here that like they have self short and self long. I'm guessing short and long maybe refer to like time to access, right? So probably what's happening here is he's going like, hey, I need this thing, and so I'm going to like shove this thing maybe onto the stack, maybe just back it up to a different register. Like who fucking knows? But like we're putting it somewhere that's like kind of like not where we want it, right? And then presumably somewhere else he copies back from long to short. You know what I mean? Code gen in x86-64. Now, we did see also that this is explicitly ignoring the error trace register, which is interesting. So the error trace register is handled like completely differently. But if we are going to have to do something similar to this in the thread local case, maybe in the thread local case, we just emit a gen call here instead of doing it at the emit stage. Right? Because then we get all of this shit for free. If that is possible to work. Right? Because we haven't really looked at that part yet. But there's this like TLS get outer stuff. And so he is kind of saying like, where am I? I am looking at reloc info, which is coming from like, where am I? While lowered relocations len is greater than 0, we iterate over these lowered relocations, where lowering, I think, is like the concept of taking like a higher level construct and turning it into like something else. So if you have like, access thread local variable, you can lower that into call thread local storage get, do other thing. You know what I mean? Like you might have something that's like call function at a higher level, and you might lower that into set all of my registers, then emit the call function, then back up those registers, then like restore the registers, right? I think that's kind of like the idea of lowering. I don't really know. But here he's iterating over the machine instructions, and their machine instruction abstraction has, I guess, like well, maybe this already says lower. So that's like he's already iterating over lowered. So I don't really know what that means. Where does this like thread local variable thing come from? x86 emit type is TLV. So in code instruction, where is this TLV thing happening? This is already an instruction. Thread local variable. What is macho? I feel like macho is not relevant for some reason. Macho doesn't sound like something like a word I recognize, so I'm not really like... So maybe I'm confused. Maybe TLV is, maybe I'm mixing TLVs. So this guy's saying if, what? If type resolved is thread local, then I say I'm TLV here. Then when he sees TLV later, he emits this get adder if I am in an elf file. Try new call immediate thing. Yeah. If they're doing link libc, then they emit this TLS get adder. Otherwise, they call nothing. Which is also interesting. Mako is the macOS binary file, like alpha and like hand wavy. Okay, that was my understanding. Yeah, that's now that you say that, it's like a thing that I'm remembering. Like I've heard that before, but I did not remember it when I was looking at it. I knew it didn't feel right. Was about the extent of it. Yeah, it really feels like for us to get the information here to be like restore registers that we need, it's like we're fucked. There's no way we can do this here. Right? It seemed like where we were, like during code gen was like the place. So that makes me think that like what we should be maybe doing is kind of like moving this decision up. He says with no understanding of the code base. Right? Like, okay. So what is happening here? He's like, I am probably accessing a thread local variable. I'm like looking over relocatable info and I'm finding like some symbol and I found some thread local variable symbol. And so if I see that thing, then if we were trying to move this thread local variable somewhere, instead of doing the move, we call TLS get adder. And then copy into that register from Rax, which is the return variable from this guy. What happens if it wasn't, like in the case where we're not linked against libc? What the fuck happens here? Like, am I high? Like, it seems crazy to me that, like, oh, I see, sorry. This is, I see. So there is a TLS get adder that is not coming from libc as well. Which is maybe like their own embedded one. I'm a little confused by that. There's like summon Moosel. I would love to not link libc here. Although I guess when we're building, we're not necessarily, we don't type -lc, so maybe it's the same. Right, when we do this like build lib, you know, we're not typing this. Right, which feels like it's different. You know, a little bit. So that's interesting. So no matter what, he's calling TLS get adder. But if, okay, can we like not link libc? Is that like a thing that we can do here? LDD lib so or .so. Statically linked. Okay. Okay. So he doesn't link libc, but so can we find this? Maybe this is in another library. I don't really understand. So this guy's saying like, I don't know what this like PLT thing means. What does this mean? I'll ask the idiot instead of, well, yeah. What does this mean in the suffix of a disassembled function name? Right? Like, you can see that it looks like he's turning this into like a relative jump, like call instruction, right? It kind of feels that way, right? He's like moving something into some register, and then he's like jumping to some offset from the instruction pointer. So there's like something there. Per function trampoline, yeah, okay. Calls to external shared library functions in the code are compiled to call the corresponding PLT entry instead of calling the library function directly. Oh, right. So everyone in this library can call TLS get attr PLT, and now we don't all have to encode our instruction offsets individually. We only have to encode, like, figure out this one instruction offset here. And then I'm a little bit confused about, like, how, if this thing isn't in the shared object, that he knows that that's always in the same place. But maybe there's like some special rules about this somewhere. Okay, that makes sense. So no matter what, whether or not we, as the library, are linking against libc, we are expecting this TLS get attr symbol to be somewhere. Okay, that's clear. And so, like, I feel like if we're not pick. So this is position independent. If we are position independent, we have to call TLS get attr. But if we're not position independent, then we just emit this directly. So they say, hey, could you do a move from this guy? I don't know what init sib means. I would assume sibling, but I don't actually know. But he's copying from this space in memory to Rax. And then what's going on here? What the fuck does this mean? Lowered instruction ops 0. What do you think this is doing? So the mnemonic is load effective address or move. Oh, I see. So he's like getting the thing from memory, putting it in Rax, and then putting that where calling the like instruction that they actually wanted to call to move from Rax into wherever they're trying to go to. I see. I guess I don't understand how thread local storage works. Right? Init sib keyword base reg fs. Like, what the fuck am I looking at here? Is this going from source to des, do you think? Rax maybe starts with the system v calling convention. Where is it? It's somewhere in here. Here. Yeah, Rax is just the return register, right? He's not even used as the input. So I'm confused. I'm a little confused. So this TLV instruction, he might be a load effective address or a move. He's like, it must be, it has to be, right? It has to be move from Rax into wherever we're trying to go. It has to be, which means that this would be move from memory into Rax, who is pulling the address from the FS register unconditionally, maybe. So one of your issues saying you can't reproduce in the Zig version, I can reproduce on tip. So I think that it might be more related to like maybe my Nix OS libc is doing something different than theirs. You know what I mean? I think that's more likely, right? It's probably that the bug is still present, but it doesn't manifest on their system. You know what I mean? It's like we're doing something incorrect, but like because their system is set up differently, it doesn't get hit. That would be my guess, but I don't know. Okay. So the big thing I would assume here that like the correct answer is thread local variable access should be modeled as a call a level up. That's how I feel. Where is this like TLV coming from? So this is on relock info. So like what is happening here? We are iterating over our machine instructions. And he is calling lower mer on this thing, which takes this machine instruction and like he's got some pseudo thing, like pseudo instructions, I guess. They're all pseudo. Or there's lower generic. Okay, here we go. Right, so they might have... These look like they're just like mapping pretty directly. I don't really know. Lower encode. They have some fixes in here, which are these guys. Sure. I don't really fully understand why this layer exists. However, we did see a like comment somewhere that said the main purpose of MER is to postpone the assignment of offsets until ICEL. I don't know what ICEL stands for. Is there an ICEL.zig? Instruction selection would be my guess. x86 ICEL. Yeah, so I assume that this is like you emit something and then later you can clean it up with knowledge of maybe like where you are in the binary after linking and stuff, right? When they talk about smaller encodings of jump instructions, it feels like it's like because you know the address, so this is like after link time because emission is after link time, you can make better decisions. So that's probably what's going on here. So this guy is going to output some sort of lowered instructions, right? For each of these lowered instructions, then he is also going to look at relocations. Is relocations part of this? Where was the relocation stuff? That is in this if? That is in this loop. So in this loop, we say, hey, we have some relocations, and one of those relocations might be a thread local variable, right? Yeah, here. So then, like, am I stupid? For lowered instructions, like, where do they do things like emit like a fucking call instruction? Like, or like a add. You know what I mean? Like, these are all relocations. This is emitting debug info. Okay. Like, somewhere, don't they have to do like add? Like, am I stupid? If lowered instructions len is 0, who knows what the fuck is happening here? I must be missing something. Maybe this lowered is used somewhere else as well. Oh, here, in code instruction. Here we go. I missed this. So this is where they're going to do like fucking rip that shit out. I see. So this is doing some like extra patching for relocation stuff, where he's like, hey, um, oh, maybe I understand here. So it might be something like, because this is like a variable access, right? I know at link time where things are going to be, like my global thread local variables. And so this is the correct time to resolve their locations because I know where they are because we're at link time ish, right? This is like called by like elf stuff, right? So some part of this does need to live here, right? But in fact, maybe this doesn't necessarily have to change, right? Maybe this doesn't have to change at all. Maybe the trick here is that when we emit the thread local variable access from the code gen stage, we check if we think it is going to call TLS get adder and then inject a fix up after. Or we convert it to a call up front. Maybe something like that. You know what I mean? Something along those lines? I don't really know yet. I have no fucking idea. But that feels kind of right. Okay, so I think what I'm kind of seeing here is that like this is super fucking reasonable, right? Like ignore the part where we're doing like fpic bullshit where we have to call TLS get adder. This is so fucking reasonable, right? He's just going like, okay, you wanted to do a load of a thread local? Let's just fucking do a load of a thread local. Like, don't fucking tell me what to do, bitch. And like, I know where it is, so we're gonna do that right now. And so my guess here is that like we're trying to represent the pick version of this thing the same, and maybe we can't. Do we have that information at CodeGen time? Like, do we, like, we have, pick is kind of part of emit stage, which is kind of interesting. Can we just look for in CodeGen if like the tag pick appears anywhere at all? Pick. Yeah. Yeah, okay. So we have examples where, you know, if they are trying to generate some code for a switch, that they have cases where they're like, they check if they're elf and if they're pick, so that seems good. Can we look for like thread local in here? Okay, so we're at line 173,000. Oh, nice, dude. We also have this shit. Right? We have another fucking example of someone with the same fucking problem, I think. Oh, this get blame is going to take a year, right? But it looks like they're kind of saying like, hey, we know we're going to be using racks no matter what, but on some platforms, we're going to be using other registers as well. Oh, okay, this isn't really what I was looking for. But it seems like it feels like we could do something like this, right? Else if we are elf and we're in pick mode, then we have to spell fucking everything. RDI, RX, R9, what of our, like, RSI, RDX, right? We have to fucking spell everything. RDX, RCX, R8, right? Because, like, we don't know. We don't know. Yeah. 1, 2, 3, 4, 5, 6, 7. Yeah, that feels right. I don't fucking know, man. Let's see. Fuck! Expected statement found semicolon. Fuck you. Where? Oh, I see. It's because I added like the little curly braces there. It'd be kind of cool if this fucking worked. If this works, we're fucking real compiler devs. Let's fucking go, baby. Okay. So let's throw a something here. I don't know what yet. Build lib. Oh, but we have to fix the test case scan. Hold on. So Zig is now calling the old thread local access shit. And let's see. So we're hoping if we look at the disassembly here, and do something, we're hoping to see after the TLS get adder here. We do not see any R9 bullshit here, I don't think. It looks like he's putting this in RDX here. R9 to Rax. Stack pointer to RDX. RDX to RX. Oh. I'm actually not sure. Stage 3 build was what we were doing before. So we build our executables with stage 3. Then we build the lib with stage 4. I'm not sure this is right. Just because we spilled the registers doesn't mean we restored them. You know what I mean? I think we forgot to pull them back after. You know what I mean? Like, this spilled register, don't they have to pull them back after? You know what I mean? That's kind of weird. Maybe there's like a defer restore somewhere. Because like, surely these guys have to behave differently. Like, so maybe we assume. Okay. And also, I do think that the code looks different. Okay. Move this guy here. And can run zig out bin exe. Okay. Let's see. Still seg fault. Okay, so it's not fixed. That makes sense. Or pick second one isn't reachable. Oh, so true. That's a really good point. That is a good point, huh? Yeah, we can try that. Good eye. Good eye, good eye, good eye. Hello, have a nice day. Hello. What a nice guy. What a nice guy. He doesn't belong here almost. He's too nice. I would never say hello, have a nice day to anyone, I think. Am I the asshole? Am I the asshole? I've never said have a nice day to anyone in my fucking life. Okay, let's try this again. Do something. Okay. Where's our TLS get adder here? We do see... Let me use this backwards. Do error here is where we're gonna get fucked. Oh yeah, here! Wait, this is really good. This is really good. Look at this. 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 Look. Sorry. I'm excited. I'm excited. But look at this, look at this, look at this, look at this, look at this. They're reloading R9, baby. I think we fixed it. DLEXE. Let's fucking go, baby! That's pretty sick. I think that's the fix. That's like a one-liner. Fucking easy, dude. Fucking easy. So we're just saying like, hey, look, man. We're elf files. We're picks. Everything's fucked. Now try to do the whole VLC plugin. Yeah, I guess what we should do here is first, let's try to build this whole thing with stage 4. So stage 4 Zig build. And then I think we backport the fix to 0.15.2 because otherwise building the VLC plugin will be a pain in my fucking ass. Right, unit test and submit upstream patch. Yeah, I think I'll probably do that off stream. I do want to, yeah, I have to think about what to do. Well, let's do the VLC plugin first. Let's see if we fixed the entire VLC plugin. That'd be fucking cool. Oh, I'm in the wrong fucking folder. Oopsies. Oopies. Yeah, let's try the VLC plugin. If it works, that's fucking hype. And then, if that works, I have to think about what to do next. Because I think that I probably want to go off stream and write the tests and submit because I want to get it in. I want to win the race, you know? I want to get my first Zig PR in if I can get it. So that's probably what I'll do. Nice. Okay, cool. So now we go, yeah, let's backport the fix to 0.15.2. You put everything under if thread local. I think we only care about this as if thread local. I think. Pretty sure. I'm pretty sure that's where it was before. What am I looking for? 0.15.2 probably. Git checkout. Git stash. Git checkout 0.15.2 maybe. Git stash pop. Merge tool. Uh-oh. Okay, what we do instead is we just redo it. Git stash pop abort. I guess we just give up. Okay, so we had, is thread local? Oh fuck, git status, git checkout. Is thread local? Perfect. And so the fix was, this was like this was like this, and then we said if mod pick and fuck, what was it? Target O format. Rax, RDI, RSI, RCX, RDX, R8, R9. There we go. And then I think we need to like rerun the whole build here. I guess we can actually just do, we can just build this with, instead of the stage 3 compiler, we can just build this with like our Zig 0.15 proper, right? We can do this. If we do something like, if we go into this, and then here, can I do like, can I do zip, like they had like, they were doing the stage 3 build. Like, can I just do this? Does that work? No, because he's trying to link LLVM shit, so I need to get in the shell again, and then I'm on the wrong version of LLVM. I might be. I guess we'll see. I guess we'll see. Fuck. Alright. Fine. I guess we do the whole build again. I hope that Zig 015.2 used the same version of LLVM. Because if not, we're going to be annoyed. LLVM. 20.x. Fuck. This is where Nix is wonderful. Because now we can just replace 21 with 20. And I think that the build might be a pain in the ass. But might be fine. Okay, focus up. Okay, we were trying to compile the VLC plugin with our fix and see if it actually works. Where is this? Zig? Stage 4? Bin Zig? Build. Do not nuke the stage. Yeah, it would be funny to just like fucking rip it. Alright. And then in here, I think we need to turn LLVM is off. Good. Alright. Stage 4 build. This will be slow, but not that slow. Maybe like 20 seconds. That's my guess. That's my guess. Dude, I do this so much now. I feel like, is this Trump hands? Where did this come from? Like, uh-oh. I feel like it's like leaked in. I can't stop myself. Okay. We're getting there. Hello plugin. I guess he's recompiling the standard library again for the first time, which is like fine, we'll leave. Caught, yeah, caught. My advent of code day 10 solution, I had a very weird thing happen on my M1 Mac. The function that did the calculation returned E64 and took 9 seconds to crunch, but when I changed the return value to 120, it took 5.5 seconds. Weird. Weird. Why would that happen? Weird. Okay. Do you think it's gonna work? How do we run this thing again? VLC like this? Wait, let's fucking go, guys! That's the look, it fucking works! Our fucking plugin works! We can see him, we can see show already watched. Which means that everything's doing what it's supposed to do. We see the dump of this. So after, what was that? 2 streams? 2 streams? We can fucking compile a plugin. Let's just like triple check that this is not using an LLVM. Let's fucking go, baby. And so now a compile change, like a little quick update here, should go way faster, right? If we change plugin.zig, and in here we say, we like remove this like mega annoying log. Why? Hello? Why is this taking so long again? Maybe the cache is busted? That happens sometimes. Oh, is it like ZLS is doing some shit? That happens sometimes, where like like I've got a ZLS running that's like running a build that's touching the cache and fucking stuff up. Okay, I want to make a change kind of without that context. Because this whole point, the whole point of all of this was to make it so that rebuilds were fast. And so if we're not there, we have a fucking problem. Okay. So we let him go, I guess. Give him a minute. We let him finish the first build, who needs to rebuild like the standard library and shit, because we just nuked the cache. Then, hopefully, you're using a debug compiler, no? Stage 4 is debug, right? Is it? Oh, fuck, it is. God damn, God fucking damn, fuck. You're right. God fucking damn it, dude. Let's go! We gotta build! Okay, thank fucking God, man. I'm gonna fucking lose my shit. release build. Okay. So we want to know, is like how much fast, like, is it fast now? That's the question that we're trying to answer, right? That's the question that we're trying to answer. Is if we do a little quick little compile, like a quick little edit compile loop, is it fast now? So std debug print. Hi mom, I'm on TV. That's pretty good. That is a lot fucking better, right? We're fucking there, baby. Right? Because with the LLVM, it was kind of more like this. Well, not like this. We have to give 2 times. We have to give him two chances. Yeah, more like that. So this is like, okay, we'll do a time. We'll time it. Hi mom, I'm on TV too. So we'll do time here. 5 seconds. This is so funny, complaining about 5-second compilations after just compiling for 40 fucking minutes. It's just a funny little thing. Okay, so we went from 5 seconds to hold on, I forgot to hit time. 5 seconds to 1.8. That's pretty good. That's pretty good. All of this, 2 days of effort, an hour of compiling, and we get fucking 3-second faster compile times, baby. Let's go. All right. Now you get the benefit from the native CV images. Oh, Trap Exit, thank you for the raid. I think we are probably going to pass you guys on. I think that we call it here for today. Unfortunately, you missed all of the interesting part. But we kind of did a little bit of spelunking in the Zig codebase, found a little bit of a fix for a thread local storage access problem we found. I'm going to clean it up off stream, get it in, or at least submit a PR and see if they fucking hate it. And we'll see how it goes. But thanks for sticking around, guys. We'll be back tomorrow with, probably we'll do Advent of Code. Probably. We have to do day 10, 11, and 12 still. We're behind. So we're going to have to get there. But cool. This probably goes on the YouTube, I think. But maybe with the foosball stories cut out. If you're watching on YouTube, there's a Patreon. There's a YouTube member. There is Twitch subs, and all of those get you access to full streams. So I'll probably post the like unfiltered stream on Patreon and then the cut down version on YouTube. If you want to see me talk about foosball for 30 minutes, you can go check that out. Otherwise, I think that's it. YouTube, peace out. Twitch is fun someone to raid.